Lighthouse Scientific Education presents a lecture in the Introduction to Chemistry series. The topic is classification of matter. Material in this lecture relies on understanding of the previous lecture, fundamental properties of matter. We will begin our discussion of the classification of matter with an introduction to the basic forms of matter. These include pure substances with atoms and compounds, and then there are mixtures, which can be broken down into two major types, homo and heterogeneous. And finally, we will discuss the procedure for classification of matter with examples. The atom. The smallest building blocks of matter are called atoms, and that's going to be the smallest at this level of chemistry. The word atom comes from the ancient Greek term uncuttable, because it was argued that there was some smallest size matter could be broken down into. Nowadays, uncuttable means that an atom cannot be broken down into smaller pieces by chemical means. A branch of chemistry called nuclear chemistry deals with the cutting of the atom and is covered later in the course. For now, we will not concern ourselves with that aspect of the atom. Almost all matter is composed of atoms. Atoms come in different forms or types, and these are called elements. The study of chemistry is a study of elements. Fortunately, there is a marvelous tool to help us organize and develop our understanding of elements, and it is called the periodic table of elements. The table may initially look complicated, but as you move through the course and become exposed to its properties, it will show itself as a valuable ally. Many familiar names are on this table, like hydrogen, carbon, and oxygen, among others. An important distinction needs to be made here. An atom is a single bit of its type of element. That is, the carbon atom is a bit of the element carbon. So an element describes that type of matter, whereas an atom is a bit of that type of matter. More on that later. On to molecules and compounds. Atoms and ions, discussed later, can be combined to form molecules and compounds. Combining and rearranging atoms into molecules and compounds is a major focus in the study of chemistry. Molecules and compounds are made up of more than one atom bonded together in a fixed proportion. That is, each type of molecule has the same kind and number of atoms. The most familiar example of a molecule is water, and its equally familiar formula H2O. It is comprised of one oxygen atom, colored red here, and two hydrogen atoms, colored white here. Water always comes in the proportion of 2 to 1, hydrogens to oxygen. The oxygen we breathe is a molecule, O2. It is called molecular oxygen. Since oxygen, O2, is composed of only one kind of element, it is referred to as elemental. That is a distinction that will become important when we discuss how to classify matter, so keep it in mind. Another common substance is table salt. It is a compound, not a molecule. Molecules are a type of compound. The distinction between molecules and compounds is not really important here. The term compound is more generally used because it includes molecules. And now we have our basic forms of matter: atoms, molecules, and compounds. Our next subject is purity. Pure substances contain only one type of substance. Substance is a term that refers to a particular kind of matter with uniform or the same properties. Water is a substance since each drop of pure water has the same property as every other drop. The take-home lessons with pure substances cannot be broken down into simpler substances by physical means. Physical means include techniques like cutting and freezing. Now, pure substances can be atoms, molecules, or compounds. All substances made of just one type of element are pure. So something that is all carbon is pure, all silver pure, all neon, all gold, all lithium, pure, pure, pure. What about molecular oxygen, O2? Well, it only has one type of element, oxygen. Even though each molecule is made up of two oxygen atoms, it is also pure. We will say that all elemental compounds are pure. That goes for elemental nitrogen, N2, and elemental hydrogen, H2, as shown here. Substances made up of just one type of molecule or compound are pure. Water, that is just made up of water molecules, are pure. Water and salt are both pure substances, unless mixed together, in which case they would be called mixtures. Mixtures are made up of two different substances which are mixed but are not combined chemically. There are no new chemicals upon mixing. Examples include milk, rocks, and sand. Mixtures do not have a fixed composition. A good example is lemonade. Lemonade can be very sweet if it contains a lot of sugar, or can be sour if it doesn't contain a lot of sugar. The amount of sugar is not fixed in making lemonade. Individual substances retain their particular properties. Staying with the lemonade example, the sugar is still sugar, the water is still water, and the lemon juice is still lemon juice, even though they are mixed together. Compositions of a mixture can vary. Lemonade can have pulp, some have added strawberries, and most have added ice. Not all mixtures of the same type are alike. Mixtures can be categorized based on how substances within are distributed. There are two major classifications. The first is homogeneous mixtures. Included here are single phase or state, just solid, or just liquid. Refer back to fundamental properties for definitions on states. Any mixture that has a uniform or the same composition and properties. That can be summed up by saying one bit looks and acts like another. Examples include salt water, gummy bears, and coffee. And then there is heterogeneous mixtures. These can have a single or multiple phases, liquid and solid. But they can have varied composition and properties throughout the material. One bit looks and acts different than another. Examples include rocks and salad dressing. Pick up a rock. Notice how it varies in composition. Well, that concludes the overview of the distinctions or classifications of the types of matter. Next, we will construct a decision tree that will allow us to properly categorize different forms of matter. Substance decision trees. Most matter can be categorized with two questions. Categorizing matter into elemental, compound, and hetero and homogeneous mixtures is done by asking the following questions. Start by asking, can it be separated physically? That is it possible through laboratory processes like sifting or spinning or boiling, really anything that doesn't cause new chemicals to be made? Is it possible to get the material of interest to separate into parts that have different compositions? This question decides whether a substance is a pure substance or a mixture. If the answer to the question is no, then it is a pure substance. If the answer is yes, it is a mixture. The next question is dependent on the answer to this question. For pure substances, ask, is it a single atom type, or is it a single element type? This separates elemental matter from compounds. For mixtures, ask, is the composition uniform? Here, uniform means same all over. This question separates hetero and homogeneous substances. It is important to note that classification is not learned by memorization. Rather, it is a process of asking smaller questions that combine to a larger understanding, which is how much of chemistry should be approached. Combining the questions into a tree will help us quickly categorize matter, and that tree looks like this. Start with a substance of interest. It can be anything. Ask the first question. Can it be separated physically? If the answer is no, it is a pure substance. If the answer is yes, it is a mixture. On to the second question. If the answer to the first question was no, ask, is it a single atom type? Remember, this includes matter we defined as elemental. If the answer is yes, then the substance is categorized as pure and an element. If the answer is no, then the substance is pure and a compound. Backing up the tree, if the answer to the first question was yes, it is a mixture, the follow-up question will be, is the composition uniform? If the answer to that question is yes, then the substance is a homogeneous mixture. However, if the answer is no, then the substance is a heterogeneous mixture. 4 possible classifications using 2 questions per substance. Before we start with a few examples to help clarify this procedure, a little disclaimer is in order. Since there are only 4 categories for all of matter, there will inevitably be material that is in the gray area between categories. That means not everyone will put every material in the same category. Just so you know. We mentioned table salt earlier. Its chemical name is sodium chloride, NaCl. The first question we ask is, can it be separated physically? The answer is no. Now, is it reasonable for a student starting chemistry to know this? Not really. Consider the process of matter classification in the early part of your class as an exposure to the concept of types of matter and an introduction to new terms. So, salt is a pure substance. What is the next question? Is it a single atom type? Well, sodium part, Na, is in the periodical table. It's number 11. And there is something like chloride at number 17. So, not a single atom type. Let's go with no. That makes sodium chloride a compound. Substances that will lead to a compound classification include baking soda, sugar, and cooking oil. Substances that are similar but not compounds include flour, honey, and syrup. How about gasoline? Can it be separated physically? Yes. Gas is a product of distillation and is really a blend of different petroleum products. It is a mixture. To the next question. Is the composition uniform? Is one drop like another? Yes, it is. Gasoline is a homogeneous mixture. Examples of homogeneous mixtures include honey, most beverages, those without pulp or carbonation, air, paint when stirred, and rubbing alcohol. And the helium in a balloon, can it be separated physically? No, it can't. It is a pure substance. Is it a single atom type? An inspection of the periodic table shows helium at number 2. So, yes, helium is an element. Again, if the substance is found on the periodic table, it is an element. That includes iron, potassium, mercury, gold, and silver. And what about stainless steel? Can it be separated physically? These classifications of metals that are not on the periodic table are tricky. Brass, for instance, is a mixture because it can be made with different combinations of copper and tin, not a fixed composition. Stainless steel is a fixed composition, and it is not really separated by physical means, so no, it is a pure substance. Is it a single atom type? There is no stainless steel or just steel on the periodic table, so again, the answer is no. It is a compound. Other metals that are compounds include cast iron and certain coins. These are both what are known as metal alloys and have fixed composition. The term fixed composition is important here. And finally, we return to our sweet, delicious lemonade. Can it be separated physically? Yes, it can. If a glass of lemonade is left outside for a few days, the water will evaporate, leaving sugar and lemon residue. Is the composition uniform? Well, if it is made with a concentrated lemon juice, without pulp, and there are no ice cubes in it, then it is yes. It is uniform and therefore homogeneous. If, however, it is made from real lemons, then the lemonade will have little bits of pulp in it, and then it is heterogeneous. Pulp and ice are different phases or states than the water, which can make one drop of lemonade different from another. Examples of heterogeneous mixtures include seawater, salad dressing, breads, soil, sand, rock, milk, right out of the cow, it will have fat globules, and wood. Of course, there are many more examples, but these should be a good start. Let's recap what we've covered. The smallest building block of matter are called atoms. Atoms come in different forms or types. The forms are called elements. Molecules and compounds are made up of more than one atom bonded together in a fixed proportion. Pure substances cannot be broken down into simpler substances by physical means. Mixtures are made up of two different substances which are mixed but not combined chemically. Homogeneous mixtures have uniform composition and properties. Heterogeneous mixtures have varied composition and properties. We developed a tree that helps us categorize matter. The first question we ask is, can it be separated physically? If the answer is yes, we ask, is it a single atom type? That gets us element or compound. If the answer to the first question is no, we ask, is the composition uniform? And that parses the material into homo or heterogeneous. And that concludes the lecture on classification of matter. Take what you've learned here and practice categorizing matter. This subject needs repeated successes and failure to develop as a skill and to begin the foundation of chemistry.